10:54 in the morning, Greenwich time, late afternoon on the island of Sumatra, somewhere beneath the town of Pematang in the rolling volcanic highlands of North Sumatra. The earth stops pretending to be still. There is no warning. There never is. One moment the streets of a city home to more than 260,000 people are moving through an ordinary Saturday. Motorbikes weaving through traffic, vendors calling out prices, the smell of grilled satay drifting from roadside stalls near Lake Toba. The next moment, the ground itself seems to exhale, a slow, deep shudder rolling up from 170 kilometers below the surface. And for a few long seconds, more than 11 million people across the island feel the world tilt beneath their feet. The United States Geological Survey will later fix the number at magnitude 6. 9. Indonesia's own agency, BMKG, will call it something slightly smaller at first, 6, 4, before revising upward as more data streams in. The discrepancy is not incompetence. It is the nature of chasing a monster that moves faster than the instruments meant to measure it. What is not in dispute is this. Somewhere beneath Sumatra, tectonic forces that have been building for centuries just found a new way to let go. And this is not an isolated event. This is the third earthquake above magnitude 6 to strike Indonesia in barely 24 hours. Less than a day earlier, on the other side of the archipelago, the ground near the islands of Flores and Sika in East Nusa Tenggara ruptured catastrophically, a magnitude 7. 7, shallow, violent, and lethal, tearing through communities that had no time to brace. Bodies would be pulled from collapsed buildings in the days that followed. Landslides would bury stretches of highway. And now, as rescue teams in the east are still counting the dead, the west of the country trembles again. Something is moving beneath Indonesia, something vast, ancient, and largely invisible to the people standing on top of it. To understand what just happened in North Sumatra, you have to go down not just the 170 kilometers to the Quake's hypocenter, but further into the deep architecture of the planet itself. Indonesia sits atop one of the most violently active tectonic boundaries on Earth, the Sunda Megathrust, a colossal fault line where the Indo-Australian plate is forced beneath the Sunda plate at a rate of several centimeters a year. It sounds slow. It is not slow. Over decades, that creeping motion accumulates into stress fields of almost unimaginable power, locked in place by friction, waiting. This particular boundary stretches for more than 8,000 kilometers from the mountains of the Himalayas in the west all the way to the volcanic arcs of Papua in the east. Sumatra sits near its heart, a long, narrow island straddling one of the most dangerous geological seams on the planet. Beneath it, the Indo-Australian plate does not simply slide flat and smooth into the mantle. It bends, it fractures. It generates earthquakes not only along its shallow, locked interface with the overriding plate, the kind of quake that can trigger tsunamis, but also much deeper within the slab itself as the descending rock is stretched and twisted by gravity and mantle pressure. That second kind of earthquake is what struck Pematang, a depth of somewhere between 90 and 180 kilometers. The estimates vary by agency, but all agree it was deep, far deeper than the earthquakes that make headlines for triggering walls of water. This is what seismologists call an intraslab earthquake, born not at the boundary between two plates, but within the bent, twisting body of the plate that is being swallowed. It is, in its own way, the sound of subducted rock screaming as it is dragged down into the furnace of the mantle. There's a strange mercy hidden inside that depth. A shallow earthquake of this magnitude, breaking the seafloor close to the surface, can displace enormous volumes of water and send a tsunami racing toward coastlines within minutes. A deep earthquake, even a powerful one, rarely does. Indonesian authorities confirmed quickly that there was no tsunami threat from the Pematang quake. The energy that reached the surface arrived diffused, softened by the sheer mass of rock it had to travel through. Powerful enough to be felt as far as 70 kilometers away in Medan, a city of more than 2 million people, but not powerful enough at that depth to tear open the seafloor and displace an ocean. That distinction, shallow versus deep, is the difference between a frightening tremor and a wall of water erasing a coastline. It is a distinction the people of Sumatra know intimately, because this island has already lived through the worst version of that story. Rewind 22 years. December 2004. Off the west coast of Sumatra, a shallow megathrust earthquake of magnitude 9. One of the most powerful ever recorded by modern instruments, ruptured a fault line more than 1,000 kilometers long. The tsunami it generated crossed the Indian Ocean and killed roughly 230,000 people across more than a dozen countries. It remains, to this day, one of the deadliest natural disasters in recorded human history. That catastrophe was not an anomaly. It was the same tectonic system, the Sunda megathrust, releasing centuries of accumulated stress in a single world-altering instant. 14 years after that, in 2018, A shallow rupture near Palu on the island of Sulawesi triggered a localized tsunami combined with soil liquefaction, so violent that entire neighborhoods appeared to slide and dissolve into the earth. More than 4,400 people died. And decades before either of those events in 1992, a tsunami off Flores killed roughly 2,500 people. The very same region, almost the exact same coastline, that has just been shattered again by this month's magnitude 7. Indonesia does not experience earthquakes the way most nations do, as rare, isolated catastrophes separated by long silences. It experiences them as a rhythm, a dangerous, unpredictable, sometimes lethal rhythm, but a rhythm nonetheless, because the country sits directly atop the point where three of the planet's major tectonic plates grind against one another: the Indo-Australian, the Sunda, and the Pacific Plate system further to the east. This is the same tectonic framework that gives Indonesia its volcanoes, more active volcanoes than almost any other nation on Earth. And its earthquakes are, in a very real sense, the same geological story told through a different instrument. Which brings us back to Pematang Siantar and to the sequence of days that produced it. The first blow landed far to the east, off the coast of Flores and Sika Regencies, where a shallow magnitude 7 struck in the evening hours. Buildings that had stood for generations came down within seconds. Hotels lost walls. Landslides, triggered by the violent shaking on steep volcanic terrain, buried sections of the Trans-Flores Highway, a winding mountain road spanning roughly 700 kilometers that connects the island's coastal towns, cutting off the very route that rescue vehicles needed to reach survivors. Power failed across large sections of the region, and with it, communication. The head of Indonesia's National Disaster Management Agency confirmed that rescuers had recovered dozens of bodies, most concentrated in the districts of Sika, Manggarai, and East Manggarai, with dozens more reported missing. Aftershocks followed in rapid succession, one measuring above magnitude 6 within hours of the main event. And then, less than a day later and more than 1,800 kilometers to the west, on the opposite side of the Indonesian archipelago, North Sumatra shook again. First a 6, 4, then, as agencies recalculated, a 6, 9. A third major earthquake in a single rotation of the planet, striking a country already stretched thin, already burying its dead in the east, already running short on the resources a disaster of this scale demands. Are these earthquakes connected? It is the question every seismologist gets asked within hours of an event like this, and it is a question that resists a simple answer. Flores and North Sumatra sit on entirely different segments of the same broad tectonic system, separated by well over 1,000 kilometers of ocean, volcanic arc, and intervening fault structures. In the strictest technical sense, one earthquake did not directly trigger the other through simple mechanical transfer of stress across that distance. The segments are too far apart, too structurally distinct for that kind of direct causation. And yet, the deeper truth is more unsettling than a simple yes or no. Indonesia's earthquakes are not really separate events happening to occur close together in time. They are localized releases within a single, continuous, restless system, a network of plate boundaries under constant evolving stress, where every major rupture reshuffles the pressure map for everything around it, even structures hundreds of kilometers away. The archipelago does not experience isolated earthquakes, so much as it experiences a slow motion, centuries-long negotiation between plates, occasionally interrupted by violent punctuation marks. In North Sumatra specifically, the tectonic picture carries an additional layer of danger that has nothing to do with the offshore megathrust. Running the length of the island, roughly parallel to the coast, lies the Sumatra Fault, sometimes called the Great Sumatran Fault, a major strike-slip structure that slices the island almost in two from north to south. Unlike the megathrust offshore, which handles the head-on collision between the Indo-Australian and Sunda plates, the Sumatra Fault absorbs the sideways, oblique component of that collision, the part of the plate motion that doesn't push straight into the trench, but instead shears laterally along the island's spine. It is this fault system that threads directly beneath the region around Lake Toba and Pematang Siantar, a landscape shaped as much by volcanic history as by tectonic violence. Lake Toba itself, the largest volcanic lake on Earth, is the caldera scar of a supervolcanic eruption roughly 74,000 years ago, so immense it is theorized to have altered the global climate for years afterward. This is a landscape built, quite literally, by catastrophe, layered again and again over geological time. For the residents of Pematang Siantar, Tebing Tinggi, Kabanjahe, and the smaller towns strung along the base of the North Sumatran highlands, none of that deep history matters in the moment the ground moves. What matters is the sound, a low groan of concrete and steel, the rattle of window glass, the involuntary human instinct to grab a child, a parent, a doorway. Witnesses described tremors lasting only a handful of seconds this time, nothing like the prolonged violence reported from the shallow rupture in the east, but seconds are enough. Seconds are enough to crack plaster, to send objects sliding from shelves, to trigger the particular disorienting nausea of a floor that briefly refuses to behave like a floor. Emergency officials in North Sumatra moved quickly to calm a population that had, quite reasonably, spent the previous 24 hours watching news of a national tragedy unfold on the other side of their own country. BMKG confirmed no tsunami threat. Authorities urged residents to remain alert for aftershocks, but reported no immediate deaths or major structural collapses tied directly to the North Sumatra event. A small mercy, purchased almost entirely by that stubborn geological fact of depth. A quake buried 170 kilometers down simply cannot deliver its energy to the surface with the same surgical structure-toppling force as a shallow rupture just beneath a city's foundations. But mercy, in seismology, is always relative and always temporary. Because deep intraslab earthquakes like this one are not disconnected curiosities. They are, in the language of seismic hazard science, evidence, physical proof that the subducting slab beneath Sumatra remains under enormous internal stress, still bending, still fracturing, still transmitting energy upward through hundreds of kilometers of rock. Some researchers who study the Sunda megathrust have long warned of a different, far more dangerous possibility hiding in the same tectonic neighborhood, a so-called seismic gap, a stretch of the offshore megathrust near the Mentawai Islands, off Sumatra's west coast that has not ruptured in a major shallow earthquake for well over a century, even as the plates continue grinding beneath it, storing energy with nowhere to go. It is not the deep earthquake beneath Pematangsian Tar that keeps those scientists awake at night. It is the shallow one that hasn't happened yet. None of this is meant to suggest inevitability on any particular timeline. Earthquake science remains fundamentally unable to predict the day, the week, even the year a specific rupture will occur. What the data does allow is a kind of long-range pattern recognition. And the pattern along the Sunda arc is unambiguous. Stress accumulates for decades or centuries, then releases in bursts, sometimes as isolated moderate quakes like the one beneath North Sumatra, sometimes as generational catastrophes like December 2004. Indonesia's geography places roughly 270 million people directly across the width of this hazard zone, spread across more than 17,000 islands, many of them low-lying, coastal, and reachable only by narrow, landslide-prone mountain roads, exactly like the one buried in Flores this week. There is also a human infrastructure story unfolding quietly beneath the geological one. In the hours after the Flores earthquake, disrupted power and communication networks slowed the flow of information from some of the hardest-hit villages, leaving officials to piece together casualty figures village by village, sometimes hours or days behind the actual scale of destruction. When a second and third major earthquakes strike the same country within the same rotation of the planet, that strain compounds. Emergency personnel, medical supplies, structural engineers capable of assessing building safety, even the psychological bandwidth of a national government. All of it is finite, and all of it was already being spent in the east, when North Sumatra began to shake in the west. This is the quiet, unglamorous reality of disaster response in an archipelagic nation prone to overlapping crises. It is never really one earthquake. It is always a sequence, and the sequence tests not just the ground, but the systems built on top of it. For the scientific community, each new event in this cluster becomes another data point feeding into models that try to map, however imperfectly, where the Sunda system's remaining stress is concentrated. Every recorded aftershock, every depth measurement, every slight revision in reported magnitude between USGS, BMKG, and Germany's GFZ agency sharpens a picture that is still, after more than a century of instrumental seismology, only partially resolved. Scientists can describe with confidence the mechanics of what happened, a deep intraslab rupture within the descending Indo-Australian plate, generated by internal stress rather than direct plate boundary slip, propagating upward through nearly 200 kilometers of rock before reaching a population of millions on the surface. What they cannot yet tell you is what comes next, whether this is the system releasing pressure harmlessly in small increments, or the early tremors of something building toward a larger reckoning further down the line. That uncertainty is, in its own way, the most honest thing that can be said about living on top of the Sunda megathrust. The people of Pematangsian Tar returned to their evening on Saturday, largely unharmed by this particular quake. Buildings checked, aftershocks monitored, ordinary life resuming with the particular resilience of a population that has learned, generation after generation, to keep functioning atop unstable ground. But 200 kilometers to the north, in Medan, the shaking was still felt strongly enough to send office workers into the streets. And 1,800 kilometers to the east, in Flores, rescue crews were still working through collapsed buildings and blocked mountain roads, still recovering bodies, still searching for the missing, beneath a landscape reshaped in seconds by a much larger, much shallower, much crueler earthquake from the very same tectonic family. To fully grasp why a single deep tremor near a mid-sized Sumatran city commands the attention of seismologists on the other side of the planet, it helps to step back and look at the wider catalog of earthquakes this same stretch of coastline has produced within living memory. The 2004 megathrust rupture was not a one-time aberration that the Sunda system somehow got out of its system. Barely 3 months later, in March 2005, a magnitude 8.6 earthquake struck near the island of Nias, just off Sumatra's northwest coast, itself one of the largest earthquakes of the 21st century, killing over 1,000 people and serving as a stark reminder that a megathrust segment, once it begins releasing stress, does not necessarily stop with a single rupture. In 2009, the city of Padang, further south along the same coastline, was struck by a magnitude 7.6 earthquake that killed more than 1,000 people and left tens of thousands of buildings damaged or destroyed. In 2010, the Mentawai Islands, that same seismic gap researchers have flagged as overdue for major rupture, produced a tsunami-generating quake that, while smaller in magnitude, proved unusually efficient at displacing water, a phenomenon seismologists call a tsunami earthquake, where the rupture moves slowly enough to generate a disproportionately large wave relative to its magnitude. Layer all of these events onto a single map, and a pattern begins to emerge that is less about any one earthquake and more about the character of the boundary itself. The Sunda megathrust does not release its stored energy in one tidy, predictable increment per century. It ruptures in clusters and segments, sometimes triggering neighboring segments within years or even months, sometimes staying locked and silent for well over 100 years, while pressure quietly builds. Understanding the Pematangsian Tar earthquake, then, is not really about understanding one deep intraslab rupture in isolation. It is about recognizing it as the latest entry in a very long ledger. A ledger that includes some of the deadliest natural disasters human civilization has ever recorded, and one that is nowhere near closed. There is a reason global seismologists, not just Indonesian scientists, track this region as closely as they track the Cascadia subduction zone off the coast of North America, or the Nankai Trough off Japan. All three are what geologists call locked megathrust systems, places where two tectonic plates are pressed together with such friction that they do not slide smoothly, but instead stick, accumulate strain over decades or centuries, and eventually release that strain in a single catastrophic slip. Japan's experience with the Tohoku earthquake and tsunami of 2011, a magnitude 9, a zero event that killed roughly 18,000 people, despite Japan possessing some of the most advanced earthquake engineering and early warning infrastructure on Earth, stands as the starkest possible illustration of what a fully unlocked megathrust segment is capable of, even in a country built to withstand it. Indonesia, by contrast, is a vast archipelago of more than 17,000 islands, many with limited seismic building codes, limited early warning coverage, and transportation networks, like the Trans-Flores Highway now buried under landslides, that were never designed to survive being cut in half by the very disaster they exist to help people escape. This is why the emergency response architecture in Indonesia carries a weight disproportionate to any single earthquake's death toll. When the magnitude 7 struck off Flores and Sika, the immediate crisis was not only the collapsed buildings and the confirmed fatalities climbing past 40, then approaching 50. It was the secondary collapse of the systems meant to respond to that first collapse. Roads blocked by landslides meant ambulances, generators, and search and rescue teams could not reach some of the hardest hit villages for hours, sometimes longer. Power outages meant that in the critical early window when accurate casualty counts matter most for allocating resources, officials were often working from partial, delayed, sometimes contradictory reports radioed in from isolated districts. Indonesia's National Disaster Management Agency, known by its Indonesian acronym BNPB, has spent years building out satellite communication capacity and rapid deployment response units precisely because of scenarios like this one. A shallow, high-casualty earthquake striking a geographically fragmented region where the roads themselves become victims of the disaster. Then, less than a full day later, before that same response, apparatus had even finished its initial damage assessment in the east. North Sumatra began to shake. It is worth pausing on what that timing actually demands of a national government. Indonesia's disaster agencies do not have the luxury of treating each earthquake as a discrete, sequential event to be resolved before the next crisis begins. Helicopters, engineering teams, and emergency medical personnel already committed to Flores could not simply be redirected westward without leaving that ongoing crisis undersupported. In practice, this means each new earthquake in a tight sequence like this one forces a form of triage at the national level, a calculation made under enormous time pressure about where the marginal life saved by additional resources is greatest. It is an uncomfortable, largely invisible dimension of disaster response, one that rarely makes it into news coverage focused on magnitude numbers and casualty counts, but one that shapes, in very real terms, who receives help and how quickly. For the scientists monitoring instruments in Jakarta, in Golden, Colorado at the USGS, and in Potsdam, Germany at the GFZ, the technical work continues regardless of the human strain unfolding on the ground. Within minutes of the Pematangsian tar rupture, automated systems had already estimated its magnitude, depth, and likely shaking intensity across the surrounding region, feeding that data into models used to issue rapid alerts. The slight disagreement between agencies, USGS settling on 6, 9, BMKG initially reporting 6, 4. Before revising is not a sign of confusion so much as a demonstration of how earthquake magnitude is actually calculated. Multiple independent seismic networks, using different station configurations and different algorithms, converge toward a consensus figure over minutes and hours, not instantaneously. In the earliest moments after any major earthquake, the number reported to the public is always a best estimate, refined as more waveform data arrives from more distant stations. It is one of the quieter ironies of modern seismology that the exact size of an earthquake is often better understood hours after it happens than in the panicked minutes immediately following it, precisely when the public most urgently wants a definitive number. What those refined numbers eventually confirmed about the North Sumatra quake was, in relative terms, reassuring. A depth of somewhere close to 170 kilometers placed the rupture well within the intraslab category, far too deep to meaningfully deform the seafloor or displace the volume of water required to generate a tsunami. The shaking intensity map that followed showed the classic signature of a deep event, a broad, diffuse zone of moderate shaking, spread across a wide radius rather than the narrow, violent, structure-collapsing intensity typical of shallow quakes directly beneath population centers. 11.6 million people, by some estimates, felt at least moderate shaking. Millions more felt it lightly. And yet, in the hours that followed, no confirmed fatalities were attributed directly to the North Sumatra event. A striking contrast to the devastation still being tallied in Flores, and a data point that will likely be cited for years in academic papers, exploring exactly how much depth alone can mitigate an earthquake's surface impact. But reassurance of that kind carries an expiration date, because the underlying tectonic engine that produced this earthquake has not gone anywhere. The Indo-Australian plate continues its slow, relentless descent beneath Sumatra at a pace too gradual for any human to perceive directly, yet fast enough, over geological time, to have built the volcanic highlands, the deep offshore trench, and the entire chain of islands that make up western Indonesia. Every earthquake in this sequence, the catastrophic shallow rupture near Flores, the deep intraslab quake near Pematangsian tar, the string of aftershocks trailing behind both, represents a small, localized transfer of stress within a system that is, at its core, still very much in motion. Seismologists studying the Sunda arc describe the underlying hazard not as a countdown to a specific date, but as a standing condition, a permanent structural feature of life for the more than 50 million people who call Sumatra home, and for the roughly 270 million who live somewhere across the wider Indonesian archipelago. There is a particular kind of vigilance that develops in places shaped by this kind of recurring hazard. Not panic, but a low, constant background awareness that most visitors to the region never notice, until they feel the ground move for the first time themselves. Building codes in Indonesia's major cities have improved substantially since 2004, particularly in Jakarta and other high-density urban centers, incorporating lessons learned from the Indian Ocean tsunami and subsequent major quakes in Padang and elsewhere. Early warning systems, though still uneven in coverage across the archipelago's more remote islands, have expanded significantly, with tsunami buoys and seismic sensor networks feeding data to BMKG's monitoring centers around the clock. And yet, infrastructure investment in a country of more than 17,000 islands can never move as fast as the tectonic forces it is racing to prepare for. A persistent structural mismatch between the pace of geology and the pace of human construction. As the sun set over North Sumatra on the evening of the earthquake, life in Pematangsian tar resumed its ordinary rhythm with a speed that might surprise outside observers unfamiliar with how quickly communities in seismically active regions learn to recalibrate after a moderate, non-destructive shake. Shops reopened. Traffic resumed its evening flow. Families checked on elderly relatives and rattled nerves settled, even as phones across the region buzzed with news from Flores, where the human cost of the same restless tectonic system was being measured in a very different currency. It is a strange kind of parallel experience. Two regions of the same nation living through two versions of the same underlying story on the same weekend. One a near miss, one a genuine catastrophe, both traceable to the same subduction system grinding beneath an archipelago that has never known true geological peace, and if the deep history written into its volcanoes, its calderas, and its fault lines is any guide, never will.